Hello, my name is Carlos Scuderi, and I will be presenting my final project assignment for CIS 9467. In this case, I will be introducing the viewer on how to use Excel Solver in order to improve IT security in today's economy. Before going into much detail into the project, it's important to address the relevance of IT security. Today, we can see a high variety of companies and organizations that are being attacked. Starting from hospitals in which entities are being required to pay ransom in order to regain access to their systems, to political parties which have their servers hacked and then the information being disclosed without authorization, as well as actually IT companies that are being attacked and then their passwords is stolen. So there is actually no company that can be fully secure against attacks, and this is the whole intention of today's project. Now, we will be assessing the allocation of resources. We'll be looking at different variables, starting from the general expectation for management about the reduction of costs and the increase of profits. We'll be looking at how we are going to be allocating the resources and whether we can allocate them here in the United States or consider an option to send them offshore. And then the highly relevant discussion of the execution of tariffs and how importation tax can impact the allocation of resources. So overall, we are going to try to answer three critical questions. So first is how typically management could be allocating resources to production plants in the US and Mexico without the use of Solver. And when we use Solver, how that could change the overall equation and what would be the potential impact to the US workforce. And then finally is, given the discussions about the implementation of tariffs, if those are implemented, how that can change the overall calculation and who will be the winners and losers. The overall information in this report has been extracted from real and made up data, and certainly for the real data, the information has been anonymized to protect overall confidentiality. Now we are jumping to the overall Excel calculation. We start from the initial report. So here in the report, we see the customers who own the different systems that they are being, for example, supported by a company. I have chosen Symantec in this case. The type of server's name, the type of operating system, and then here's what we will be working on. Every system could have problems. The problems have different levels of criticality, starting from almost normal, what we call severity normal, all the way to what we call it criticality fatal. That means that the deviations found in every server are not all the same. Some deviations would be more important than others, and this is one of the criteria that we are going to be using to focus our work. But before we start focusing on work, I will show you a general overview that potentially management might be using at the very beginning. Here we see on the left side an overall table with the customer name and then the total count of issues which has been identified, organized in descending order. And here we have an overall pie chart with the list of customers. Again, the name of the customers have been anonymized to protect their identities. Also, we can see a view of by operating system, again organized in descending order of issues identified, and we can see already that Windows has most of the problems. And then finally, the different criticalities. Here it's important that obviously we have 200,000 entries, so 200,000 problems that they need to be fixed. We will be focusing only on critical and fatal issues, and even with those, we'll be doing further prioritization. So in order to do that, I have created a pivot table. We will be only looking at critical, so I have created an initial filter here for critical, and then we have the role labels organized in descending order. Same for fatal and but for fatal we have far less issues, so this is a little bit easier to filter. Now moving to the different three scenarios that I have calculated. First of all, we are in the first scenario, we are allocating resources without the use of solver, as I said at the very beginning. Now, all of the three scenarios will share similar tables, meaning the constants. The first table will discusses the overall costs of resources, both for the production side in the United States and Mexico. Slightly cheaper in Mexico than in the United States. And the material cost here, there is a little bit of a difference. In Mexico, we are considering that the cost of, for example, purchasing software could be higher. And then other costs, and here's when we are factoring in the importation tax or the implementation of tariffs. Over here we have the overall capacity of the site, and the demand of basically is the list of issues that we want to solve. So the list of issues actually will come from the pivot of priorities. Over here is a general calculation of the amount of time in hours that it will take to fix each one of them. And finally here will be the overall assignment of work. Now for the first scenario, what I have said is that we will be assigning resources more or less using or giving priority to the US worker. So we'll first start allocating the work for United States up to a point that we will find a potential bottleneck, in this case in the Windows team, which will result in shifting production to Mexico. The total cost is about $12 million, again without the use of solver. For scenario number 2, now we are using solver, which means that we will be giving equal importance to both the production in Mexico and United States. So we will not be giving priority to United States, and we'll be calculating a scenario assuming free trade, meaning that we do not have any tariffs in place. Everything else in the calculation remains the same. So over here we can see already the results from solver, but if we click on data and then we look for solver, here's the list of constraints and the set objective. We are using GRG nonlinear, and then we'll click on solved. We can see already that we have reached a result which basically provides this allocation of resources. Already we can identify that we have a lower overall production cost or total cost, and we can see that the production has shifted to Mexico more than in the United States. In the third solver scenario, now we are giving equal priority to United States and Mexico, but now we are assuming that there is an implementation of the well-known 25% of tariffs importation of services from Mexico to United States. Again, we are discussing services. We are not discussing the tariffs like aluminum or steel, but again, this is just an hypothetical scenario that we are considering. Everything else in the general calculation remains similar. So now let's go to data, and then we'll run solver. Again, we are using the same variables, the same objective. We are trying to minimize it, and then the cells that they are changing here, the overall constraint. We'll click on solved, and here solver is telling us that has identified the best possible solution, and here's the end result. So we can see already that some of the workload has shifted back to United States, and we have less work in Mexico just by looking at the total bottlenecks. Again, we can see a little slightly higher. So who have been the winners and losers? So in order to easily identify the end result, I will move here to the final summary table. So on the summary table, we see from the production side in the United States, the total production and capacity utilization. This is in total hours, and this is the total percentages. Now for the total percentages, I have created spark lines that show that the initial allocation, obviously we had a higher utilization when management was allocating resources, but then when we use solver for the first time, the overall usage has gone down. But then after the implementation of tariffs, it has gone up. So at first sight, it will be clear that we have more work in the United States. So a U.S. worker could see this as an overall win. Still, on the other side, the total cost has basically gone with the same trend. So we started with a reasonable low cost, then we brought it further down, and then we had a bump in the total production cost. Over here, it's another view using a different chart, a column chart, where we see the total capacity utilization for the different roles from network engineer all the way to quality assurance, where we see a reduction and then an increase. So overall, we have seen an increase after the tariffs, but again, at the expense of the company having more costs. So I leave it up to the viewer to determine who is actually the winner and loser. Thank you very much for your attention.